In this video presentation, we will be looking at the Events API. The content of this video has been extracted from the Moodle plugin development by example course from Moodle Publishing. But before we start, if this video proves to be useful and informative, please don't forget to like it. And if you haven't already, please subscribe to this channel for more useful content in the future. If you are so inclined, click the bell notification to be informed when we upload new content. Right, the Events API. The new Events API was developed in Moodle 2.6 and then became a requirement in Moodle 2.7. And it basically extended previous legacy events and logging APIs. The later versions of Moodle since 2.7 still have support for legacy systems, but eventually all that is going to be deprecated. Components or plugins that want to capture events have to define observers. And observers, it's an array that's defined in the events.php file in the DB folder, in the plugin or components DB folder. Observers can never or should never cause a fatal error. They're not supposed to disturb the actual process itself, but they can raise exceptions if there is an error, which are then caught and then sent to the logs. You can view all the available core and plugin events by going to the events list in the reports section of the site administration. Observers are defined in an observers array, as I said, in the events.php file, and each of the array members has the following keys. So each observer, each item in the array has the following keys. It's got the event name that you're trying to capture. So it will be the fully qualified event class name, or you can have a star for all events. The callback, preferably an auto-loaded class, but if not, you can then specify the include file, which will be included, and then the callback function called. Priority, the priority is defaults to 0, but observers with higher priorities are notified first. So if you need to be very early in the process, remember you can't really do anything with the data. You can't change the data, etc. All you're doing is observing that the event has happened and then taking some action based on that event. So, but there may be a case for you wanting to be called very early after the event has been triggered. And then internal. So this defaults to true. If it's set to false, which is non-internal, then the observer is not called until after the successful transmit of any database transaction. So this is what your events PHP file would look like. So you've got your observers array, and then you've got your items in the array with the specific callbacks, etc. So really, in a sense, you really need the event name and the callback if it is auto-loaded, but you'll need the include file if the class isn't auto-loaded. And so that's an example of what your file would look like. On the other hand, the processes or the components or plugins that wish to register or to dispatch events, called dispatchers. So all events are logged, so there's no need for any separate logging. And they have to be defined in namespaced files in the classes event folder. So this is one of the examples of where namespaces are a requirement, and this is to work with your event API. The naming of the class, the convention is a some object action, where action is a verb such as created, added, etc. And there's a list of recommended verbs on the Events API page, and there's a link there for you to go and have a look at. There's quite a fairly long list of actions that you can specify. Okay. All definitions are extending the core event base class, and they are basically triggered by calling the trigger method of the class. Every event is expected to be defined in a separate class file, and that's part and parcel of your namespacing auto-loading requirements anyway. So for example, you've got the core user created event is defined in the classes event user underscore created PHP file. So you see how that works. And we're going to create a dispatcher, and you'll see it in action when we do that. The event class has numerous properties, a lot of which are actually automatically computed when the event is triggered. But there are others that need to be declared by the developer. So there's some static properties that you normally set in the init method of the event class. So object table is the database table of the record that's being affected, and it requires another field which we'll talk about in a bit. This CRUD, again, all these three are actually optional. CRUD, which indicates whether this is a create, read, update, or delete operation, and the edu level. Again, the idea with edu level is supposed to help with reporting. So you've got the edu level of teaching, so something that's part of teaching, or an event triggered by the act of teaching, or the act of participating is the next level, and then anything else is level of other. So the other event properties, these would normally be passed when you create the class. So when you pass to the constructor as such, okay. So you've got the object ID. Now the object ID is required if you've defined object table. It is the ID of the actual record in the object table that's being affected by the event. The context ID is computed for the context passed in. So you need to pass in the context, and then the context ID is actually computed from that. The user ID is required, but again, if you don't pass through a user ID, it will default to the current user ID, or it will set it to 0 if the person's not logged in or the system's not logged in, and -1 for other kind of things that will have created the event or affected the event. The related user ID is where another user is being affected by the event. So for example, if you're the admin and you're amending another user's profile, then your user ID will be your admin ID, and your related user ID will be the user ID of the person or the record that's being updated. Okay, and then you can set an anonymous flag to say whether the action is anonymous. There must be a use for that somewhere. And then a very useful one is other, which is any other data that you want registered for the event. This is where it's useful for logging. This is where you can put your details of what you're logging in the other, which is a JSON encoded scalar or array. Okay, as I mentioned there, the optional object ID relates to the record ID in the object table property. So it makes it easier to actually identify the record that's being affected by the event. Now, in the case of deletions, the record will not be there by the time the event is observed. So in the case of deletions, the add record snapshot is a useful method and is recommended for any deletion. So you basically take a snapshot of the record that's being deleted, and then the observers will call the get record snapshot to actually get a copy of that record. Now, what has to be borne in mind, that snapshot only exists for the duration of the event. There is no copy of it stored for later retrieval unless you do that in the event itself. Okay, so it's basically there solely for the use of observers during the event. So for example, if you have database records that are reliant on, let's say, an enrollment record that gets deleted, then you pick up the fact that the enrollment record has been deleted. You can look up the details of the enrollment, so you could get the enrollment ID or the enrollment type, etc., and then delete the connected record in your own tables based on that. So that's quite useful. And then I mentioned the other, which is really useful, especially for logging, so you can put in some data into the other property, and that will end up in the log table. So let's go back and define our own dispatcher. So back in our ID, let's create our folder for our event. So we have a new folder called classes. and a subfolder in there called event. So, and in there now we create a new PHP file, which will be report viewed PHP. So our usual stuff at the top. We're in a namespace, so we've got to give it a namespace. Namespace is always the first thing in the file, even before the defined Moodle internal. So we've got that. So our class is called report viewed, and it extends core event base. Okay. So we talked about the init function in the presentation. So the init function, you don't have to define it, but it is useful for setting those statically defined properties. So in here we set the data to CRUD and the edu level to other. So this is being done so that the statically declared properties will be set to these. Okay. Then there's some methods you need to override. First of all, get name, and this returns the human readable name for your event. And then get description, which is the description of the actual event. And we need to define some strings for both of these. And then the get URL, which is normally where the event would have been triggered. So we now need to define our strings. We've added in the two strings, our report viewed and the description. Notice the use of the A variable. Where's that A coming from? If we swing back to our class, you can see we're passing a third parameter, this user ID, in the description. So that will be what will appear when this description is generated. Now, there's not much we can do. If we try to go back to our plugin in Moodle, etc., there'll be nothing to see because we need to trigger that event for it to happen. We also need to view the report. We need to be able to view the report. So that will require us actually now defining or setting up or creating our index.php file. If you remember, we're pointing to our index.php file. So that's it for the presentation. To watch other extracts from the course, click on the playlist link, or alternatively, watch the video describing the course content. Don't forget to subscribe and like, and thanks for watching.